Day with the topic Measurement Information in the Digital World. My name is James Fetchak. I've been with NIST in the United States for about 20 years. I started as an associate and became a federal employee in 2007. From 2007 to 2019, I spent most of my time in calibrations and research in the pressure and vacuum area. I started as an associate, tried to do a little work in the vacuum area. In 2019, I became the Associate Director for Measurement Services at NIST. And at that time, I became involved in the worldwide effort for digital transformation of metrology. And now I represent NIST on the SIM Technical Committee for Digital Transformation of Metrology. And I'm also on the AMECO Technical Committee for Digitalization, the TC6. Okay, so today I'm going to be the host for this event, but before we start, it's important that you know some the specific guidelines for the event. First of all, the event will be recorded from the beginning until the end. Second, please use your microphones and cameras. Your microphones and cameras must be turned off unless you're specifically asked to do otherwise. 3, you can use the chat to ask any question to the speaker at any time, but we're going to answer them at the end of the speaker's presentation. Fourth, right after the event, a short survey about today's experiences will appear. And so please take a little time for this because it's important for the feedback to improve the work for future events. So again, everybody, please mute yourselves and turn off your cameras if you're not if you're not a presenter. So this workshop is organized by the Metrology Working Group 14, what we call the MGW14 of the Inter-American Metrology System. And our objective with these events is to promote the digital transformation in the region and make liaison with similar organizations. The MWG is the link between the SIM working groups and the digital transformation. The MWG 14 has 6 task forces to specifically work in subjects that interest the region, and I invite you to participate in them all. And in a moment, we're going to put those task force in the chat with the contacts. So I'll just name them very quickly. They are the Metrology for Industry 4.0. They are the Automation of Laboratory Processes. They are the Digital Transformation, the Digital Calibration Certificate, the Agile Projects, Cloud Technologies for Metrology, and what we call follow-ups and support. Also, I would like you to invite you to check out our website, where you may find information about the task forces and activities and other events. And you're also going to find videos and several presentations. The web page will also be put in the chat in a moment. Okay, so our first speaker today is going to be, we're going to have 2 speakers, Dennis Camara from NIST and Mark Kustner of NCLSI. And Mark will be our first speaker today. Mark will speak on standardization, digital calibration, and measurement capabilities. And Mark holds a degree in electrical engineering and physics and consults with 31 years of metrology experience. He chairs the NCLSI metrology practices and MII automation committees. He writes the metrologists towards a measurement information infrastructure column and manages editing for the NCSLI Measure, the Journal of Measurement Science. NCSLI's Measurement Information Infrastructure initiative seeks to standardize automated data exchange for metrology. And I also invite you to check out Mark's most recent article in the issue of the NCLSI Metrologist. It's a very, very good article on the same topic that he is talking about today. So welcome, Mark, and please go ahead with your presentation.
Thank you, Jim. Hello, everyone. Thank you. You see my screen okay?
Yes, okay. Yes, Mark. We see it.
Great. So thanks for everyone for your attendance. As Jim said today, I want to talk about standardizing digital CMCs, hopefully a topic that interests everyone. After a short introduction, we'll discuss digital transformation just a little bit and how taxonomy fits into that. We'll look at developing a taxon and CMC for airflow as an example of how we build these in the MI context, and look at some other further examples to get a more rounded view with a short conclusion. So with that said, here's a few acronyms and such you may or may not have seen just for reference. Primarily today, we'll discuss the MII and the taxonomy for CMCs and touch a little bit on the M layer. So just a quick blurb about NCSL for those of you unfamiliar. Initially established in 1960 as an American organization. It's now an international organization, has been for some time. As Jim mentioned, we published a couple of magazines, a journal, various standards and recommended practices. In 2015, NCSL convened the 141 committee to focus on this MII concept. And so we've been working on these things since then. You may find further information at this Wikidot site. So just a quick summary of digital transformation. So I think everyone's familiar with this, just so we're clear on the ideas. This slide shows a progression from the old days of manual operations through analog technology, digitization. This is our first of three terms that we want to disambiguate: digitalization and digital transformation. You can see where in metrology we've gone from typewritten certs to most folks issuing certificates in PDF form. We really haven't caught up with the rest of the industries that have fully transformed themselves. But we hope with initiatives like the MII, the DCC and such, that we'll get that digitalization in full swing and enable some of the innovations that will result from digital transformation. So although we are behind, we have started, and as everyone knows, with BIPM and OIML and various other organizations having signed a joint statement to this regard, I think everyone's behind it now. The second point that I want to make with this slide is just that simple digitization doesn't suffice. So if we just digitize our existing processes, we won't really gain the full value that we want from digital transformation. So we want to go the whole way. So with that in mind, this slide shows the MII concept, Metrology Information Infrastructure. We envision these three documents: instrument specifications, certificates, and accreditation scopes, as carrying the majority of the information throughout the digital metrology economy. So MII is mostly focused on accreditation scopes, but the work that we've done easily translates to these other two documents as well. So keep that in mind, because I know the DCC is at the forefront of everybody's focus these days. So to make digitalization and digital transformation possible, the machines require metadata to process these documents. So this information flows back and forth through the international quality infrastructure, but at every step we have a human interpreting, generating, and processing these documents. So we want the machines to do that, and to enable that, we attach metadata to that data in these digital documents. For metrology, metadata primarily means descriptions of the measurands, and for that we've established these MII taxons. And so, for example, you see DC voltage taxons here below. So a specification for an instrument might tag a particular function of that instrument with source.voltage.dc. And then correspondingly, a lab would advertise the capability to calibrate that function by tagging in its accreditation statement the information with measure.voltage.dc. And when you turn around and calibrate an item, those measurement results would be tagged with source.voltage.dc. And that would tie all this information together so the machines could process it automatically. You probably remember Blair Hall, I think, previously talked here about the M layer. So just a quick review on that. The M layer is based on the idea that to digitally transform our industry, we want to rethink things from the ground up. And in metrology, the ground is pretty much quantities and units. So the current systems we have for human use don't really suffice for machines to disambiguate quantities. So the idea with the M layer is that rather than writing quantity values as a numeric value in a unit, we would also attach what we call an aspect ID, such as an ID for voltage and an ID for pressure, so that digital processing for uncertainty propagation or any type of calculation would know how to handle those quantities without human intervention. And it would distinguish quantities. We call them aspects to generalize the term quantity kind, so it applies to all different scales, not just ratio scales. But for example, voltage isn't simply voltage. There's any number of different aspects and scales for these quantities. So we would be able to distinguish historical values in terms of 1990 conventional voltage versus SI9 versus SI8, et cetera, et cetera. So that M layer disambiguates the quantities for machines, but that doesn't cover measurands. So the idea with the taxonomy is to disambiguate the actual measurands that we want to communicate in these documents. So corresponding to these voltage and pressure examples, we might have any number of different measurands. For example, source.voltage.AC sine wave for alternating current sine wave measurement, or this pressure example. And in instrument spec documents or calibration certificates, there might be additional qualifiers to distinguish different features of the instrument. But each one of these MI taxons would map uniquely to an M layer ID, and so that all the quantities under that particular data section would have the proper aspect identifier to identify the quantity values. So that's the basic idea. So in this section, we'll just look at an example of developing a taxon for airflow. It's a complicated enough example that it illustrates most of the cases that we'll get into as we develop these. And what we're doing here is establishing not only a taxon, but a template for all the data that goes into CMC. We're creating an abstraction from which laboratories may create their own CMCs for their own specific situations. So as starting assumptions, we just assume that we're going to calibrate mass and volume flow meters with either air or dry nitrogen. And we're going to assume that to date in the taxonomy, we have nothing established for airflow. So we'll go through this step by step. In each step, you'll see down here in red a basic rule that we use to govern how we form these taxons. In blue, we'll see the taxon as we develop it. And in between is something of a human readable version that you might see on an accreditation scope. So first of all, we're going to start with either source or measure in our taxon, depending on the capability, whether we're sourcing a value for a measuring instrument or vice versa. In this case, we said we're calibrating flow meters, so we're going to source airflow for that purpose. Next rule just says we separate our tokens by periods. Easy enough. And then from there on, we describe the quantity in more and more detail. So we're saying airflow. And this taxon that we build is going to be a unique identifier that we put in digital documents. So it's not necessarily, even though it's fairly human readable, it's not really intended for human readable documents. So we allow a set of aliases to correspond to that. So this might be in different languages or different terminology according to a given sector. So we simply just put airflow for now. on the human readable version. Now our next rule says these tokens should follow the upper camel case convention, so we delete the spaces and capitalize the words. That doesn't change, though, the human readable version. Next, though, these tokens for the quantity name are not, the quantity kind are not arbitrary, so those need to be established in the MII taxon as unique values. So since we assumed it doesn't exist yet, we go to the MII registry, we find it out it doesn't exist. We find out the M layer doesn't have an aspect ID for airflow. So we want to do some research to figure out what kind of terminology we want to use. So if we go out to the various sources like the KCDB, the ISO 80,000 document series, as well as all the various accreditation agencies, we quickly find for these measurands that there's a whole variety of terminology and names, and it quickly becomes confusing to sort out the quantities and the terminology. But that's our job here. It's not a problem because our object is to determine a unique identifier for these. So we get busy with it. We'll go out and look at more sources, and it gets more confusing. There's terminology for related quantities like evaporation with different names, and for unrelated quantities that use some of the same terminology. So it becomes a task to sort that out, but that's what we're doing. So if we boil that down, we quickly find out that, well, maybe not quickly, but there's four basic quantities. There's mass flow, volume flow, plus ratios and coefficients. Mass flow covers leaks. There's fluids. So it's not just airflow, it's fluid flow. That could be a gas or a liquid with differing measurement processes. There's various types of fluids. You have inline and non-intrusive meters. So after looking at all that, we would propose adding 2 taxons to cover our particular needs in our laboratory. So mass flow rate and volume flow rate. And while doing so, we might come up with a hierarchy, a partial taxonomy to cover this particular measurement area. So we can source and measure these quantities. We have mass and volume flow for either gas or liquid, inline or non-intrusive meters. And you can kind of see how we qualify these taxons further and further. We also have ratios for labs that issue meter correction factors, and coefficients for those meters that say output of voltage in response to a flow rate. And I should point out that really the whole taxon matters as a whole. The machines don't really pay attention to the individual tokens except for the source and measure. So back to our steps of developing the taxon, we change from airflow to mass flow rate and concentrate on that particular taxon. And we also changed the human readable version because that's more descriptive and more specific, which is kind of a general principle that comes out of this as we clarify what goes into digital documents, because machines require that disambiguation. We also get better at writing it for human purposes. So then we just add further taxons to further qualify our measurand. So we're going to calibrate mass flow rate of gases with ambient air. And in our CMC, we can add that information too. We'll do it either with ambient air or dry nitrogen. However, another rule says that we have this parameter capability. So calibrating with ambient air or dry nitrogen really amounts to the same process. So we don't want separate taxons for that. We'll handle that with parameters. So it's similar to, say, calibrating thermocouples. There's various types of thermocouples, but the type can just become a parameter under one taxon, because it's all a volt. If you're simulating a thermocouple, it's always a voltage versus a temperature. Whereas if you're simulating a platinum resistance thermometer, it's a resistance versus a temperature. So that would be a separate taxon. So we drop the ambient air from the taxon, and we have our taxon completed. To go along with that, though, we want a definition for human purposes so that we can easily select a measurand from a list, a taxon from a list for the measurand of interest. And so if we go out and search definitions for flow, we find this in ISO 80,000. And we just elaborate on that for more clarity for someone trying to figure out which taxon to use for a given purpose. So now we have a taxon and a definition. You may have heard the American expression, lies, damn lies, and statistics. So that implies that statistics are the worst kind of lie, but they get a bad reputation simply because we abuse statistics and we don't specify the conditions under which they apply. It's the same thing with calibration. We want to define our measurands very completely so that we don't lose the value of calibration. We have this concept of definitional uncertainty, and we want that uncertainty to be relatively small compared to the other uncertainty components so that we don't swamp them out. In worst case, our definition, our measurand is so bad compared to how the instrument is used that it swamps out the accuracy specification and makes the calibration worthless. So to avoid that, we want to fully describe the measurand state. So that involves the influence quantities, input quantities, any property values, or relevant operating conditions. So this becomes part of our CMC template. And if we go out and research the process of mass flow rate, we find any number of different influences that might either alter the uncertainty or give options that the customer might want to choose between. Now, all of these don't necessarily apply to any given lab situation, so just depending on the uncertainty level, the traceability level, and the customer requirements, any given lab may drop any or all of these parameters from their particular CMC. But this is the abstract template that we want to develop to cover any situation. Now, some of these are required and some are optional. So to do any kind of a search on a capability or mass flow rate, we'd want to know the value of the flow or the range of interest. And we might want to know the values of some of these other parameters as a customer searching for a capability. But for our particular example here, I flagged all these others as optional parameters. But that also may change depending on the lab situation. So this is kind of a human readable version of the CMC template as we've completed it. So we have a taxon to uniquely identify it. We have a definition for human use. And then the CMC would encode all this information in an XML data format. So the required and optional parameters with ranges. And when that CMC is taken and filled out, it becomes a concrete CMC and an SOA. The ranges would be filled in with values, and if we attach uncertainty in the whole works. But this is our template. And if we look at it in a human readable form, if you compare this to, say, airflow CMCs that you see out there in the wild, you'll notice that this has quite a bit more information than you would typically see. But here I've listed not only the range for our CMC with a simplified uncertainty, but also the fact that it's a source to definitely disambiguate that from a measurement. And we're showing the ranges or default values of all the relevant quantities. So if the customer may select either dry nitrogen or ambient air. If they don't specify, we'll default to ambient air, we'll default to 23 degrees C, 800 kilopascal static pressure, but we have capability over this range, et cetera, et cetera. So it's much more complete information for searching and using CMCs, communicating them between organizations. Now we've worked with NRC. We're starting to work with NRC to work on some of their service codes and KCDD entries. The first one we looked at was this microphone calibration capability. So it's essentially a pressure sensitivity, a ratio of voltage to pressure. There's a couple different methods, primary and secondary. Secondary method uses a standard microphone, whereas the primary method doesn't require one. It's traceable to fundamental SI quantities. So this is some information from the KCDB entry for one of those relevant quantities, and the service code from their website. And you can see kind of a textual, human-based information here that we would encode digitally with some of this other information. And we come up with something like this as a taxon for that particular measurand. So we're measuring a coefficient and reporting a coefficient of voltage to pressure. And in particular, it's an AC voltage as an root mean square value. It's a differential pressure, also root mean square. And there's a few different options for doing this microphone measurement. So in this particular case, it's called a pressure field measurement. So we select measure because microphones source their values like a gauge block. So we want to measure capability to calibrate that source, its coefficient, and further descriptions. So you kind of get an idea of how this works. And we also specify parameters such as nominal sensitivity of the microphone, the primary parameter, as well as the influence and input quantities, frequency, pressure range, etc. Now, there's a number of other factors that go into any calibration, in this case, like cavity dimensions, impedance, various other parameters. But those typically are not something that the customer selects a service from. They're just details, internal details to the process, so they don't become part of the CMC template. And the question comes up whether the primary and secondary calibration require different taxons. Probably not. It's the same quantity, just like if various labs up and down the traceability chain measure DC voltage, they'd identify it with the same taxon, source.voltage.dc. And so that probably applies to this as well, although the pressure field token on the end may or may not apply. These are all draft taxons, and so we expect to refine them given some expert participation. We've also done a starting taxonomy for some photometric, or rather radiometric quantities that NRC supports. And here's some of the parameters that would become involved with those: wavelength, various angles, sample size, polarization types. Within the MI group, we've worked on quite a few taxons. You see some of those here. These are all drafted and out there for people to look at and give us feedback on. Here's the rest of them. So it covers quite a range, but by no means not everything. So we're looking for a lot of collaboration and support to help develop these. So just to conclude quickly, digital transformations coming our way. Everyone here knows that. We think this MI initiative gives a way to digitize CMCs and also tag the data in digital calibration certificates. So keep that in mind. As you have your DCC projects, these taxons might become useful for identifying the data in those documents. We hope they'll produce a lot of benefits and make these documents interoperable. And so we'd certainly like to collaborate with you in developing these. We've set up a site with NRC's help on GitHub for managing this collaboration, taking submissions and improving new taxons into the taxonomy. And so you can find that site here. It's currently not public, but if you send an email to Ryan White at NRC or myself, we can get you access and get you involved in that. Otherwise, our current information sits out on this website at CalLab Solutions, and there's an informal list here. CalLab Solutions has some open source software for developing this taxonomy and editing digital accreditation scopes. So you might want to look at that. And then there's, of course, there's more information at the Wikidot site. So thank you very much for your attention, and many thanks to the organizers and everyone who has supported this effort.
Okay, thank you, Mark. That was a really great presentation. I see we have at least one question in the chat, and so now we will have quite a few minutes for questions, so people can chat them in. So first question is says thanks, Mark, for sharing your knowledge. If you can clarify if this taxonomy description will be open and free available. Will it be required to subscribe or authenticate somehow to use it or to download it?
Thank you. Yes, thank you for the question. That's a great question. It is completely open. We intend it to be an open, fair source. So we're using the GitHub to facilitate that. The NCSLI committee will make decisions on the particulars of the taxonomy. However, anyone may join NCSL and become part of that decision process. Many of your organizations are already NCSLI members, but the taxonomy will be free and open, downloadable. You can actually get it now at the current GitHub site that's open. You can download not only the taxonomy itself, but also the software to edit these taxons and accreditation statements.
Just to sort of follow up on that question, Mark, is the intention at some point to turn this into a standard through through one of the standards organizations?
Yes, as we develop the taxonomy in parallel, we'll be developing the specification document. That's already drafted, so that's where some of the rules that you saw in the slides come from. But that's also a collaborative effort. Initially, it'd probably be a free and open NCSLI document, but we're certainly open to that becoming some other type of standard.
Is there other questions that are not chatted in? So just to sort of follow up on that again, Mark, what right now you have to sort of request permission to get on the GitHub to view it. So do you anticipate there will be yet an even more public mode of sharing and downloading the taxonomy in the future?
Yes, I think so. We just haven't opened it up yet. So the new GitHub site is I think about 3 weeks old. So we're still populating it with the information from our previous repositories. So yes, it'll certainly become much more open.
Seems like so how many folks are on the committee right now that are actively working on this?
Good question. Our typical meeting, we have regular Monday meetings working on this taxonomy, by the way, and we're open to establishing further meetings at different times to match up with people in different time zones. But a typical meeting has 5, 6, 7 people involved, but the committee has quite a few more involved. Fluke Corporation is working with us also to set up, they've built a draft registry for the M layer. So we'll tie the taxonomy to that once that gets more established.
Have there been any adopters of the taxonomy at this point?
Only in the accreditation statement to this point. So we think NRC is looking at adopting it. We've presented this to the APMP group, the Asia Pacific Metrology Program, and we have some initial interest from NMIJ and MSL and the UAE NMI. So we're hoping to fire this up and get some momentum going.
Yeah, Javier has asked if we could repeat the name of the NCSLI committee. Maybe we can put that in the chat. Can you put that in the chat, Mark? Just the name of the committee so they can look it up. Yeah,
I'll do that as we go along.
Somebody else asked if we could get the presentation slides of today's talks. I believe that the presentations will be online at some point after the meeting. And so Ryan asks, from the NMI perspective, the initial effort would be to define taxons which correspond to the KCDB CMC. How can introduction of the MII taxonomy in the KCDB help with adoption or standardization?
Yeah, great question. So we've had some discussions also with BIPM, and part of the idea is to link these taxons to the individual KCDB entries via their internal IDs. So it turns out through their API on their website, we can get those identifiers and make those links. But having taxons associated with each of the KCDB entries would certainly facilitate flowing this concept down through the international quality infrastructure from, everything traces to these KCDB entries. So the taxons would be very similar going down the measurement chain. And there's obviously some service codes that NMIs and other labs have that aren't directly linked to KCDB entries, but that would just require some modifications or expansion of the taxonomy. So the KCDB forms a really nice starting point for disseminating the taxonomy.
So Rodolfo has a comment and question. He says, a very good presentation. One question: what is the difference of this taxonomy effort and the BIPM digital SI?
Yeah, good question. So the BIPM digital SI primarily focuses on encoding quantities and units in digital data. So it's looking primarily at how do we represent a kilogram, how do we represent a meter, etc., in the digital data. The taxonomy expands upon that. So with the M layer, you have a little more disambiguation between units and scales, and encompasses more unit systems than just the SI. And then the taxonomy adds further disambiguation for different measurands within the same type of quantity.
Thank you, Mark. Are there other questions? So another question I had, Mark, is has there been a particular industry or area that's been more interested in this than others? I think you mentioned Fluke. That's would sort of suggest electrical measurement and temperature, things like that. Are there a particular industry area that's most interested in this right now?
I think it's pretty generalized. I don't think it's specific to any one measurement area, but there's interest from software companies, not just Fluke, but other software companies. And of course, software is the key to making this whole transformation work. So, there's a bit of a chicken and egg scenario there, but I think we'll get through that. But in terms of measurement areas, I think it's pretty generalized. The taxons we've developed cover, say, 80% of the types of measurements out there, but probably only 10% of the individual CMCs due to what's way out there in the tails. So a lot of work to do there.
So Ryan has another question. It says, with the recent CGPM joint resolution, there is a broader effort to develop the SI digital framework. The taxonomy would be an important part of the metadata. I guess that's more of a comment. I don't know if you have anything to expand on that.
Yeah, that's a good point. We're actually presenting the M layer to the CIPM expert group on the digital SI as one of the possibilities for encoding quantities and units.
Thank you. Are there any other comments or questions? If not, I think we could probably go ahead and move on, since Mark finished up a little early, and we can go ahead and start moving on with Dennis Camara. Hopefully,
Thank you.
are you ready to present, Dennis?
Yes.
Okay. So the title of Dennis's talk is the Digital NIST Pilot Project, Transforming and Modeling Digital Reference Material Certificates. So Dennis has worked at the Office of Reference Materials at NIST, we call it the ORM, for 16 years. He has led production and distribution of NIST SRM certificates, making many improvements to represent information from NIST's diverse materials in a uniform way. His duties also include leading other aspects related to reference materials, such as safety data sheet production, conversion of safety documentation to GHS, hazmat classification, label production, packaging materials, and e-commerce. Prior to working in the Office of Reference Materials, he created IT programs at NIST, including the web code for the first version of the key comparison database that was released when the CIPM MRA was signed. So welcome, Dennis, and you can go ahead with your presentation.
Thank you. Let me go ahead and share my screen. And if you can just confirm that you see it okay.
Yes, okay.
Yes, Dennis, that's good.
Excellent. So today I'm going to talk about the work that's ongoing at NIST in our digital NIST project around creating a model and transforming our materials to have digital reference material certificates, or DRMCs. At the start, though, I'd like to acknowledge a couple others that have been involved in this. My colleagues that have been involved in the pilot study, our PTB colleagues who've helped us out as well. The NIST Associate Director for Lab Programs who's supported the effort, and it's not on the slide, but also the SIM MWG14 for inviting me to come talk today. So this has been digital transformation has been a worldwide effort, and as we've already heard, NMIs around the world are pursuing various digital programs, things like digital calibration certificates, the metrology cloud, Industry 4.0, the Internet of Things, and automation and remote calibrations. This has been going on for a few years. But in general, the broad consensus is that metrology needs to move to fully digital and fully fair data. And so, as Mark referred to as well, many organizations have joined into a joint statement of intent on the digital transformation in the international scientific and quality infrastructure. And the joint statement provides a platform for the signatory organizations to come together to indicate their support in a way appropriate to their particular organization to the development, implementation, and the promotion of the SI digital framework as part of a wider digital transformation of the international scientific and quality infrastructure. So just looking at FAIR real quickly, what is FAIR? FAIR, we want this data to be findable. We need to describe it in ways with lots of metadata around it so that we can index it and we can search it quickly and find what we need. We're getting more and more data as we go through this, and it's like, I don't know, it's like if you had a huge library of books, it's going to take you forever to get through. So you need to have a way to find that data quickly. It needs to be accessible through a well-defined and universally implementable protocol. Needs to be interoperable to be able to interact with other systems. You use a formal, accessible, shared, and broadly applicable language, and it needs to be reusable. So using that rich metadata and documentation that it actually meets the relevant needs of the community. So in 2022, NIST convened a pilot project to look more in depth at what it would take to make the digital transformation here. Some of our objectives were to evaluate existing DCC schema and its applicability to the NIST calibration reports and certificates of analysis for standard reference materials. Also to assess resources required to deliver this digital data for the NIST measurement services. We wanted to get out of this as well some deliverables. We wanted to be able to create a fully digital NIST calibration report and certificate of analysis, at least some kind of prototype of them. And we also wanted to look into and create some human readable versions of these digital reports and certificates from this this digitized data. So a digital NIST will enable sharing of interoperable metrology data and other digital tools, and also serve as a repository of data. It's going to require substantial investment in data and computing infrastructure to ensure the digital traceability for all supporting measurement services. If we get to the point of, it's not if, but when we get to the point of having DRMCs, if we're still manually entering or typing in information, then we're not truly digital, and we're not going to really gain all the benefits that we can from this conversion. We do see that this is going to boost industry competitiveness in global markets by meeting international standards requirements for accreditation, conformity, quality, and product safety. The change to digital will also make it easier for customers to access the data whenever and wherever they need. So far, much of the international conversation has been focused on calibrations, especially with the DCC in its development. But it may sound trivial to say, but reference materials are different than calibrations. So reference materials, they're materials that are sufficiently homogeneous and stable with respect to one or more specified properties, which has been established to be fit for its intended use in a measurement process. And then a certified reference material is an RM that's characterized by a metrologically valid procedure for one or more specified properties. And that's accompanied by a reference material certificate that has the values, the uncertainties, and a statement of metrological traceability. So for NIST, we call our CRM standard reference materials. They have at least one certified value. Then we also have reference materials that don't have any certified values. And they may just be a material that's homogeneous and stable with respect to a specific measurand. So NIST, we have a large and diverse catalog of standard reference materials. We've been making reference materials for over 100 years, and we add new materials every year. We currently have over 1,100 different products in our catalog in 28 different categories that span many areas of science. Our SRMs represent categories such as metals, high purity materials, ceramics, foods and agriculture, cements, radioactive materials, nanomaterials, primary gas mixtures, and many more. For us, no one category makes up a large portion of the materials we provide. And one of the benefits of this diversity of materials is that this will help make the schema or model that we create more robust, because while we've worked and all of our certificates are similar in format, each of the categories provides some kind of unique information to it as well. So looking at the different steps on the pathway to digital metrology starts with digital documents. It moves through going to having machine readable documents, then machine executable content, machine interpretable content, and ends, at least for now, with our thoughts on machine controllable content. And so right now we're at the beginning stages of this transformation, which I think is probably fair to say that most people are. NIST reference material certificates are currently produced to be disseminated as digital documents as PDF files. And part of the goal of our pilot project was to be able to figure out what was needed to move from having to having machine readable documents. However, as Mark touched on earlier, I forget his exact quote, but creating a machine readable document, it needs to be more than just recreating the current certificate format in an XML format. Humans and computers process the data differently, and we need to adapt the information provided in a DRMC. The next steps need to move towards having data that can be actionable by machines, and that's not going to be the same presentation as what we provide for humans to read right now. Also, we could create an XML schema relatively quickly, just looking at the ISO requirements. However, that would be missing the context of the information. The bigger challenge is creating a model for DRMCs that represents the way reference materials are used and is usable by a majority of people. So a model is a representation of what something is and does. It can be used to predict and think about the behavior of its focus from one moment to the next. While our focus here is reference materials, the concepts of modeling apply to any other thing that we want to look at. What gives the models its meaning is that they are part of a knowledge lifecycle wherein we can learn as much as possible about something and organize all that knowledge into one place. So looking at the stages of modeling, we start with the early stage where we're just collecting data. We started looking at different certificates, what's in a certificate, looking at ISO guides and standards, et cetera, just to start collecting all this data, all this information. And once we do that, then we can start to classify them. We can see where there are similarities and where we can generalize. So that's a stage of a lot of learning to see what things align and what things are disparate from each other or different from each other. Then we can move on to a more formal stage where we start to strive to formulate these principles and rules and be able to take information and logically analyze what's going to happen if we put this information into this model or the system. And so we systematically organize the body of knowledge here. And then finally, once we have that model, then we move to the application stage where we can use technology to create something that humans and machines can understand. Although our overall goal is to get from step 1 of modeling to step 4 and have an implemented technology, the process of modeling is really iterative and frequently requires us to move backwards to a previous step as we add new data or as we learn new things, since we need to continually evaluate whether the new information fits into the model. And the important task here really is to support the accurate representation and translations of this knowledge. So NIST is one metrological organization in the global metrological ecosystem. And we have complex and variable metrological data, and we're performing incremental modeling of the data and workflow to put into a digital infrastructure. Excuse me. So some things to think about when we're engaging this kind of process is that we have individual teams and specialized data looking really at some really detailed information. But from that, we need to look and we need to find these unifying abstractions that apply across all of these specialized data. And in doing that, that's how we discover different individual components of the infrastructure. They can, sometimes they may feel like they just appear when two things click. But then as those keep getting discovered, we need to make sure that they're synchronized and that they fit together throughout the development phase. And then always keeping to push to look at the broader context to see the big picture of the model. So for NIST, in our pilot, we looked at, for reference materials, we looked at taking our certificates as they are now, converting into XML data, and then also converting them back into a human readable RM certificate. And one of the categorizations, or some of the categorizations that we saw, we based on the convergence of the type of value along with the mode of certification. That was an interesting, when we gathered together our data, seeing the the way things fell along those lines. And so we've been working to create this DRMC schema and this model that meets the needs, excuse me, that meets the needs and requirements of both NIST and its stakeholders. We looked at ISO 17034 and ISO Guide 31 to inform our model. We looked at the NIST quality manual and NIST policies. And we talked to our customers as well to get their input. The current draft schema framework breaks down the information in the certificate into 6 different areas: organization information, reference material identification, material information, context, provenance, and references. I'll talk about each of these a little bit with some examples in a moment, showing some examples of what's currently in SRMs. But I'm also going to be posing some questions throughout that are questions we can think about that help us as we go through modeling this process. So starting off with information in the organization identification section, it will identify the organization or organizations responsible for the production of the reference material that is specified, and that's information that's specified as required in 17034 and ISO and Guide 31. In addition, it provides the ability to indicate whether the producer is a National Metrology Institute, a designated institute, or another type of organization. We also recognize that there is more collaboration between organizations nowadays in producing reference materials. So the schema will accommodate listing multiple organizations and being able to describe the relationship between those organizations. The next section, information in the reference material identification section, will allow for the unique identification of the reference material so that the DRMC can be matched up to a unit in hand. Right, I mean, we've got the material needs the certificate to really be useful, and the certificate needs the material, otherwise it's just, well, currently a piece of paper, eventually a bunch of ones and zeros. So the schema will allow up to 4 levels of differentiation, including the overall product number or ID, a specific batch of material, a specific lot of material, or a specific unit designated by a serial number. And this approach should allow for proper identification of the material and units based on their homogeneity. One of the things we saw at NIST with our materials is that the majority of our materials have homogeneity that applies across multiple units. So for these SRMs, one certificate applies to multiple units, and the certificate is available to everyone. But we also have SRMs that have homogeneity that applies to a single unit. And each of those units gets a unique certificate. And those certificates only get distributed to the customer that purchases that unit. Each of these distribution types raise their own concerns and security questions. The digital certificate must be flexible enough to allow to be able to identify the entire range of units to which it corresponds, and also be able to identify the specific unit to which it applies. The security on the digital certificates must also be flexible to allow for both public availability and individual availability. So the next section is the material information section, and that contains the bulk of the information about the reference material. The data contained in this part of the DRMC is information inherent to the reference material, and it's broken down into 4 different subsections: unit description, usage information, measurement information, and additional information. So in the unit description, that describes the physical nature of the reference material. You can think of it as the product specs. Some of the information that should be stored here are things like, what is the material? Is it a liquid or is it a solid? How much of it is there? How many different parts? Are there different materials at different levels? They are included in the RM. How many of each part are included in a unit? What type of packaging does the material come in? All this information is important to detail so you know what you're getting and whether a material will work with your instrumentation. So the usage information section holds important information about storage, handling, and usage of the material. The storage information could include things like store away from sunlight and intense sources of radiation, or store in a -80 degrees freezer. And just to kind of point out there, those two examples, the first one, store away from sunlight and intense sources of radiation, that's very customized to us as humans. A human will be able to process that fairly easily, but a computer may not be able to process that quite as easily versus, say, -80 freezer. The computer can get that real easily. So the usage instructions that need to be specified will surely be diverse, like the examples I was just talking about, and store information such as things like, does the material need to be reconstituted, or does it need to be diluted? Do you need to measure, or do you need to dry it so that the measurement can be done on a dry mass basis? And how do you measure that to keep the values correct? Do you mix two parts of the reference material together to make a solution? This may be part of the schema that needs to accommodate a lot of text. And there'll definitely be challenges as we continue to model and develop this to figure out how to take that text and make it machine actionable. So now getting to the heart of the certificate is the measurement information section. And that's where we provide measured values and other important information about them. Stored here are things like the period of validity, traceability statements, what is being measured, what are the units of measurement, what are the associated uncertainties, is the value certified or non-certified, and any measurement procedures if applicable. This is the most complex part. Representation of units hasn't been solved for machines yet, and there are many different possibilities out there right now, such as things like units ML or QUDT, and other possibilities. And if you're measuring more than one value, do they have the same period of validity, or can the period of validity be stored based on the measure end? That's something that, for instance, right now, we tend to at least NIST does, we tend to have the period of validity apply to the entire material. But if we know some components are more stable than others, could we take that and say, apply different periods of validity to each of those components? The measure ends are also complex. There are many ways to represent what is being measured, such as the common name for a material, a chemical name or symbol, the CAS number, or an Inchi key. We need to look at how can we represent all of that information such that it registers with the people that are using it. If somebody's used to using the symbol versus an Inchi key or whatever, that they are able to get that information when they need it. And something that needs to be figured out with that, as well as all of this, is how much of this should be put into the schema versus how much should we then really offload into programming using XSL or something else, some other kind of middleware program to convert the data into what is needed. Right? Do we want to store all those names of the material in the same XML file and keep adding to it, or is there some way we can do that as a lookup? And which is better? That's stuff we want to look at as we model. And the types of values that we deliver in our SRMs are also varied. The most straightforward SRMs have one value and one uncertainty. Other SRMs may be matrix materials and have multiple measured values and uncertainties. There can be potentially hundreds of measured values and uncertainties in an SRM. In addition, some of the values may be certified and some may not be certified. The values, other SRMs that we have, the values are DNA sequences, and the representation of a DNA sequence is completely different from that of a value and uncertainty. And you kind of see that on the right side of this slide, the difference between those two. And they're it's so stark. So the schema that we develop, this model that we develop, must be able to accommodate these very different kinds of values. And our approach is to favor flexibility in delivering these values so that they can be delivered in the units preferred by our stakeholders. Due to the nature of the work in the lab, a user performing ignition testing may prefer to have a non-SI representation, such as a percentage, since that's what they're using or what they're familiar with. Or a user measuring coating thickness may provide measurements expressed in mils. So providing that flexibility to the SRM stakeholders is fundamental to creating a DRMC that will satisfy customer needs in these disparate technical areas. And then moving to the final subsection of the material information is the additional information, because we need to be able to store information that's not really representable by text. This includes any necessary graphs, figures, photos that provide information in ways that are easier for comprehension. Because sometimes a picture, like a chromatogram, communicates information much more clearly. These may be encoded with the schema. However, we're investigating whether they should be stored outside of the schema as well and linked to it. Those are all things we need to think about. So moving back up a level, back to the main 6 sections. The next section is the context section, and that holds the information specific to the organization that it needs to communicate. These may be things such as legal notices, maintenance statements, warranty statements, or other information that's part of an organization's policy. And then, the next section is the provenance section, which contains the revision history of the certificate. A challenge of certificates is that they get revised and change over time due to the longevity and the stability of the materials, because these reference materials can be around for quite a long time. Especially if you're using a chunk of steel, that could be, that could be around forever. So the changes that can happen can range from having a simple editorial change to extending the period of validity to adding or changing the measured value. And customers need that measurement history, especially when they're talking to auditors when they come in to show their traceability. Currently, when a certificate gets updated, it creates an additional version of the certificate. We're looking at how to incorporate that information and the changes so that maybe we can embed all of the information from previous revisions into one certificate file, so that we don't have multiple copies laying around or people using the wrong information, but that kind of, again, going back to FAIR, that historical information is easily findable. And then the last section of this model and schema is the references section, in order to cite any publications that are relevant to the certificate. So throughout the pilot, we've also been considering some additional topics in the development of the schema. Accommodating Greek letters and symbols is important because they're superscript, as well as superscripts and subscripts, as these can be found throughout certificates and units and representations of measurement. We need to look at separating the data from the text, as I was mentioning before. Humans are much more adept at reading text. However, machines read individual data points better. As we shift to certificates that are machine readable, we must change how the data is communicated. Even though we are still transitioning towards machine readable, it's still important that we have a human readable certificate. Humans will still be involved in making measurements and will need to ensure the quality of those measurements by verifying against the certificate. There's been many different ideas we've been considering throughout the pilot, and each of these provides a wonderful opportunity to make certificates more accessible and usable. And we see the potential for tremendous gains in searching to identify SRMs that fit the need of customers. And creating a repository of digital certificates to facilitate more automation and better comparison as well. The improvements that we can achieve with the digitization of certificates to be machine readable ultimately becomes the foundation to progress through these steps and become the foundation for machine-to-machine communication. There's also other advantages to this digital transformation. If we're truly digital, we can eliminate transcription errors. Right now with paper and with, we're copying data over and over. It's too easy to have errors creep in, and those errors can matter. We can have an interoperable data and unit formats. We can use digital signatures and identifiers to make these certificates more secure, and enable security in a digital traceability chain. The data will be preserved for much longer. We can have searchable databases of the information. Again, going to the fair, that it will become much more easy to find the information that you need. This could also provide a foundation for innovation in instruments eventually. I could imagine a scenario. What if when you're making a measurement in the lab, your instrument could look at the DRMC and tell you that your sample size is too small. Some of that is just thinking that we haven't even begun to think about yet what those kinds of possibilities are. We can enable web-based measurement services. As I've said before, making customizable reports and certificates that really hit at what does that specific customer, what does that specific sector need. Lots and lots of advantages. So looking at the next steps for us, we're going to continue to work on the model for NIST. We're still bouncing through those 4 steps, gathering more information, trying to make this a more robust model. But we also need to work on converting things that are currently paper-based data to be digital, so that we have that digital infrastructure behind and in place and ready when we're ready to communicate DRMC. And then the other thing is to work with SIM members. We're looking at ourselves. As I mentioned, we're listening to customers as well. But again, if something gets created and it's not usable by a majority of people, then it's the old joke. If you've got 15 standards and so you say, well, let's make a standard to combine them all, and now you've got 16 standards. Well, we don't want 16 standards. We want to have something that everybody can use. And so with that, I'm happy to announce today with the MWG14 is forming a sub-working group on DRMCs. The initial goal of this group is going to be sharing information regarding DRMC development, also to work on a DRMC schema, looking at the model and rules for schema usage, and coming up with protocols for the support and distribution of DRMCs. And then after a year, the group will present recommendations to the MWG14. I look at this as being an informal format, at least to start, as we are in the early stages. And this will be NIST-led. I'll be leading this working group. So attendance, participation in this group and attendance to the meetings is open to all SIM members. We are looking to have a representative from each participating SIM country to be identified, just to help facilitate some communication between the different NMIs. But if you are interested in joining, or then please contact either me or that you're and present BG14, and my email address is there, as well as the general digital NIST at NIST.gov email address. And I think they're also going to get put in the chat. But I want to thank you for your attention and listening, and I'll take any questions at this point.
Thank you, Dennis. That was a great presentation. We do have a few questions in the chat. I've also put your email address in the chat if you want to reach out to Dennis about the new group we're forming. I don't think we have a date fixed yet for the first meeting, but it would be fair to say it probably won't be before March, but maybe not so much after.
Yeah, it definitely won't be before March. It won't be in February. Aiming probably towards the end of March for the first one.
So we have a few questions in the chat, and so we'll get started on that. And if time allows, we can also have additional questions for Mark if Mark is willing. I think Alexi did have a question for Mark that I didn't get to. So the first question is, what about the encryption of material measurement information?
Yeah, that's a very good question. And putting this information into a DRMC, we do want to secure it more. To this point, we haven't done, we haven't looked too much into specifics about how to encrypt or what the best ways are, but we do need to look at and encrypt the information and make it more secure. I've seen with paper stuff, gosh, it's been a few years, but I've seen an example where somebody sent to us a copy of our certificate, and it was quite obvious that somebody had printed out information on another piece of paper and then taped it over the information on our certificate and attempted to present it as a valid certificate. With the move to digital, we can add encryption, probably to the whole certificate, maybe even to sign individual pieces of information, so that we know what are what's valid, not just us, but any auditor or anybody in that kind of process can know what's valid.
All right, thanks. And so the next question is from Alexi, and he asks, the additional information, is that for humans or also for machines? Must the additional information be made interpretable for machines?
So there's very good observation that I was thinking as I was making the slides. It's like the additional information seems pretty geared towards humans right now, and sure enough, it is. Does it need to be made interpretable for working and moving towards this digital method of communicating? We may discover ways to turn that chromatogram into specific data points, and to be able to make it interpretable for the machines. If I have a background in IT as well, and frequently people, they'll see an image or they'll see a web page of lots of text, and they'll get information off of it, and that's just somebody writing a program trying to pick out the relevant pieces of data. So I do think that we could take those kinds of pictures and try it. That it can lead to better quantification of those things that are very qualitative right now.
So just a sort of a follow-up on that, Dennis, would it be fair to say that some of the, like in the picture that you showed, it was a spectrum. Would it be fair to say that in a lot of cases for reference materials, people might be using that additional information to decide if that's the reference material they want to purchase, whereas the machine, once you own it, then it's the machine interpretable information that's probably the more relevant. Is that sort of one way to look at it?
Yeah, absolutely. I think that's one way to look at it. That definitely the looking at the graph can help the human figure it out. I'll also put out there my what I can't remember. I mentioned it in the talk, but one of my things I often say or say occasionally is, can you imagine that with the DRMCs, that maybe your instrument would be able to communicate directly with, the NIST catalog or different CRM producers catalog, and be able to say, oh, this is the SRM that you need for this situation, and so it may end up being the instrument that looks and figures out what it needs in the future. But
level 5 or 6.
right.
So Enrique asks, do users have to have implemented some degree of digitalization process to use digital certificates of reference materials?
So I'll say no, because what we're striving to put all this information digitally. But we can't just rely on the digital. We need to make sure that that information can be produced into something that's human readable. So if somebody gets a reference material and they haven't done any digitization yet, they can and they should be able to use that what essentially I imagine would be a PDF of certificate. It's just that PDF was created through a digital format, going through XML to create that. Because looking at it, every organization is going to be at a different point along this journey as we go. So we need to make sure that we have that compatibility, that people are still involved, and that you don't have to have an entire digital digital framework or system in place to be able to use it. So that's the long answer. Again, the short answer is no, you don't have to.
All right, thanks. So Mark asks, he says, nice informative presentation. Thank you. Has the model progressed far enough to explicitly distinguish CRM data model from the calibration data model? Do you think a higher level abstraction exists that covers both?
So let me answer the second one first. Do I think a higher level abstraction exists? Absolutely. I think there's definitely similarities between calibrations and reference materials. One of the big reasons that we looked into a model specifically for reference materials is that reference materials are based off of ISO 17034 and calibrations are off of 17025. And while there's similarities, trying to jam in reference materials and fit them into and act like they are calibrations, it wouldn't provide optimal usage for reference materials. And so in some ways, what we're doing is going back to that modeling idea. We are taking and doing a cycle of learning on reference materials, so that eventually we do want to take the model and compare it to the calibrations one and see, okay, how can they be combined? I don't think we're at that point yet. I think we're still doing a lot of learning. We're as I mentioned, we've been doing a lot of NIST learning, talking to more people in SIM, and getting broader and broader is just going to make the model and give us a better understanding of the needs for reference materials.
Yeah, thanks, Dennis. I think just sort of follow up on that. I think as part of the pilot project, we initially thought that a lot of the metadata would be similar, but at least I sort of realized that it really wasn't that similar. And if you try to force fit the metadata of the calibrations into the reference materials, it could lead to confusion. And one example, and please correct me if I'm wrong, Dennis, because you're the expert on reference materials, but one thing I thought of is like one of the pieces of metadata is the lab like that did the calibration. Well, for reference materials, there could be the lab that you bought the reference material from may not be the same as the lab that produced the reference material, which I guess in some cases could be even different from the lab that certified the reference material. And so that could lead to confusion. I don't know if you have a comment on that or not, but hopefully I got that right.
No, that's a pretty good example. Yeah. Well done, James.
Okay, we have another question in chat, and you have to forgive me on this one because for some reason the font on my chat is coming out very large on this, so it's going to be a little bit difficult for me to read. So this is from Sidley, and the question is, good morning. In my opinion, a lot of information can confuse industry. For metrological and statistical control, it looks very complete. How can we help the industry with a general report without losing focus on traceability?
So I think that you're right. When we have a lot of data, we can get overwhelmed. It can lead to confusion. And that's where it goes back to the idea of having fair data, findable, accessible, interoperable, and reusable. And it's why it's so important to have rich metadata around the information, whether it's in the DRMC, whether it's merging something like the M layer together, because once you have that metadata and you can provide the context, then when we want to get the information out, somebody's going to be writing some kind of code to do transformation. We can find and we can specify the information that is relevant to those people that are going to use it. So we can essentially ignore everything else and just focus right down on the information that they need, because we've made this information findable with this rich metadata.
Okay, thanks. And Hugo asks, he says, thanks, Dennis, great presentation. I see an opportunity to identify building blocks we can reuse between DCC, DRMC, digital certificates for proficiency testing exercises, model approval testing. Should we take into account an effort on reusable component architecture?
Absolutely. Throughout all of this, at least in my mind, I keep trying to think of how does it fit to the bigger picture. And I think you're right in naming those things that they have, that there's going to be similarities. And so we definitely should take into account reusable components. The process that we're using is to continue to model, we're learning about the reference material and then bring in the next thing, or maybe more than one thing, to be able to say, okay, kind of the same thing. It may feel like, hey, we got to the technology of the DRMC, that step 4 from my one slide. But now if we start talking about the DCC or proficiency testing, we may be back at step 1 where we've got all this disparate data and that we can look through. So we should definitely take into account those. And I'll say too that in the back of my mind, I've looked at this model for the DRMC. Really, it could be applicable to, could potentially be applicable to non-reference materials as well, because if we design it well, we can allow for the certified values to be identified and non-certified values to be identified, and it could become a way to be able to just document any lab sample that you have, taking into account just to fill out what are the pieces of information in the schema that are relevant to the material. So definitely would like to reuse parts of this.
So we have another question, but I think you may have answered it again, but you can see if you want to elaborate some more. It says, how important is it to work in parallel on computer security? This is so that all the data is not affected by the digital processing in case there's a violation of integrity of the information.
Yeah, so I did touch on that earlier. I don't know that I fully answered this, but this is a very good question. I think it's extremely important to do the security at the same time. In fact, that's some of my more recent efforts and conversations have been trying to get the security going. When we were doing the pilot, we were looking, we knew security was there and that it needs to be done for the exact reasons that you say. But we need to get that going in parallel now, because we can't develop it and then try and tack security on afterwards, because it's just it's not going to fit. It needs to be, as we say here, it needs to be baked in from early on, so that it functions effectively.
Okay, thanks. There's one more, and I think this will probably have to be the last question. Are there any tools available to producers of calibrations to create prototypes of digital calibration reports?
I am aware of some. I think actually, I know. I'm sure they'll talk more about for digital calibration reports. I'm sure they'll talk more about that next week at the DCC conference. But I think, and Jim, you may actually know some more of them since you were doing more on the calibration side. But there's like the JemmyMeg tool. I forget some of the others, but
yeah, I think if you look on the PTV, and I'm blanking on now the website name, but they have a wiki where you can get to, as Dennis mentioned, the JemmyMeg tool, and that's and maybe some others, but that's probably the best place to start right now. Okay, so thank you, Dennis. And I think there's supposed to be a survey. I don't know if that's is appearing or not, but I'm not in control of that. But I want to thank both Mark and Dennis for their presentations. And I think as one last thing, if everybody could turn on their cameras, I think they want to take a photo and of everyone. And
yes, I could like to take that photo, and I see that we are a very huge people. Then I could like to wait some moments in order to join more people. We are 100 or more than. Okay. Just 1 minute more. Okay. Well, I'm going to count from 1 to 3. 1, 2, 3. Thank you very much. It's a nice picture. Thank you, James.
Okay. Well, thank you, everyone, and thank you for your participation. And we'll see you in the next M4DT Day.
See you all.
Thank you. Take care.